In this section, we're going to write the game of life algorithm. We're going to break this task down into units of specific functionality, unit test it, and then pass those tests. And also, looking at the structure of the problem indicates the structure of the data type that we're going to use and the parameters to the function. For example, a game is built of cells in a grid. So each cell is either alive or dead, and it has a count of the surrounding neighbours, whether they're alive or dead. So we can see straight away that there's two parameters. The first parameter would be if a cell is alive or dead, and the second parameter is the addition of all the living cells. So we can group tests together with a describe. So for this, we're going to just be testing the game of life. And actually what we can do is nest descriptions. So our first function or our actual algorithm to be tested is the isLive algorithm. This is the core of the program really. So that's why we're doing it first. So isLive algorithm. So as we've covered before, a dead cell with no neighbours is still dead. Dead cell with 3 neighbours comes alive through expansion. A live cell that has less than 2 neighbours dies. A live cell that has 2 or 3 neighbours stays alive. And if a live cell has more than 3 neighbours, it dies. So the first test will be a dead cell with no neighbours. So as Ken Beck said, start small or nothing at all. We're starting with what I think is the simplest test. So we pass in alive or dead for the first parameter, and any neighbours, so that's going to be 0. And we expect it to come back 0. So we save. Jest detects that a file change has happened and it throws an error. So let's add the isAlive function. For this we can just return 0. That seems a little bit silly, but this is the whole point of test-driven development. You keep things really simple. You want to get green as fast as possible. So now we can actually focus on the next test, which would be a dead cell with 3 neighbours should return 1. Dead cell and 3 neighbours to equal 1. Yep, failed. That's great. So now we can say cell neighbours, and we can add that condition. If actually, so we need to convert boolean cell, and if neighbours is exactly 3, then we can return 1. Yay! Excellent. So our next one would be test live cell with no neighbours should return 0. Say we expect isLive. A live cell is 1. So this actually passes because this condition hasn't been met, so it falls through. So actually our test didn't fail, but that logic is correct. The code that we've written actually covers our test case. So we can start our next test, which is a live cell with 2 neighbours should return 1. Yep, that fails. So if again cast it and neighbours is exactly 2, we can return 1. Yep, excellent. Now you can see that the code itself it's not ideal. We've got a lot of duplication. So the point of refactoring is you're removing duplication. So we've got 3 return statements. We've got 2 of them returning 1. We've got a cast, which is being knotted. So again, baby steps. We can actually get rid of this code here because that's essentially an OR, 2 ifs, and just wrap that in brackets. Yep, passes. That's a little bit cleaner. Still not great. And actually, this condition is not relevant actually, because it covers both alive and dead if there's exactly 3 neighbours. So we can just get rid of that. So if exactly 3 neighbours, or if it's alive and it has 2 neighbours, let's return 1. Not bad. There's still a little bit of duplication, return, even the brackets actually. So a lot of people like the function literal, so let's actually convert this to a literal, because I think we can use an automatic return statement. So let's convert this to an arrow function. Let's actually get rid of the if and turn it to a ternary operator and just return 1. If not, return 0. Yay! So actually that code looks pretty streamlined, and actually it looks a lot simpler than when I first read the spec and how I envisioned the code to be. This is pretty much on one line. Yeah, I'm happy with that.